I will discuss about the mesh analysis. Previously we have studied nodal analysis. That means applying the Kirchhoff's current law, we find the voltage of a node. In that case, the node was defined where the current passes through a junction where incoming and outgoing currents are found. Here mesh analysis, mesh means a loop network that we will apply Kirchhoff's voltage law. That's the basis of the node analysis, and applying Kirchhoff's voltage law, we will find out the mesh currents. Okay, it's like the opposite of nodal analysis. But here we have to keep on our mind, just look at the network here. Here 3 loops has been created. Loops means the closed path, or we say that is the closed loop. Okay, so these loops are popularly known as loop currents. This is the loop current, and they are also known as the mesh currents. Particularly if you see that there are 3 loops or meshes, and if you want to find out the current, you have to apply Kirchhoff's current law. In any kind of map where the loops are not determined, you have to give the I1, I2, I3 or I4 the name of the loops at your own. But here in this map 3 loops are given. So how you can find it out? First of all, you have to give the polarity. Analyzing the first loop, that means that is I1. The current enters in this direction. The entering direction will give plus polarized portion, and the outgoing portion will give the negatively polarized. And then again the plus, minus, incoming current plus, outgoing current minus. So in this loop we have to determine the polarity first of all, and all the loop currents are in clockwise direction as you can see. Okay. Now look at it. That's an 8 ohms. And as we know that applying Kirchhoff's voltage law, we will apply KVL, Kirchhoff's voltage law, in that loop. We can find out if the voltage drop, as we know, if a current passes through a resistance or reactance, it possesses a voltage, okay, or it drops a voltage V1. That will be the so applying the KVL, Kirchhoff's voltage law, in this mesh 1, V1 plus V2 plus V3 is equal to 0. Now we have to just apply the Ohm's law in that situation. So in V1 there is the resistance 8, so 8 I1. In V2 there is 2 currents are there. This is the one direction I1 current, this is associated I3 current. So there are the different direction currents. So if we make a difference between these two, we can easily find out the resultant current across the inductance. Okay, just look at it. Just look at it at the V2 here, two directions I1 and I2. So J 10 ohms into I1 minus, and the loop current here is I3 plus, here you can see another voltage drop V3 across this capacitor. So we can easily find out the direction. That is the I1 direction and that is the I2 direction. So we can also write that is I3, I guess, minus J, as it is minus sign, J 2 ohms into I1 minus I. In this loop 1, we previously get 8 I1 plus J10 I1 minus I3, I1 minus I3, and minus J2 in that section. That will be I1 here and I2 its direction is here. So I1 minus I2, I1 minus I2. That is the first equation. After that you have to solve it like this. Just calculate all these things, separate the I1, I2 and I3, and you will largely get the equation. You will largely now you can see that we have solved the equation I1. For mesh I2, how you can solve it? So look at the mesh I1 in that section. Here is a source has been given. So there is I2, the loop is here, and according to polarity, just clarify the polarity. So income current, outgoing current direction, incoming direction, outgoing direction. Make it this direction, make it to this direction. So now you can find out easily the equation. First of all, J 2 ohms. There are two directions, this and that. So there will be resultant of the two currents. Okay, so you can easily write I2, because there is a mesh 2. For mesh 2 we are solving for mesh 2, so I2 will be the driving current, I2 minus I1. So then it will be in that direction, same as I2 minus I3, Z2 I2 minus I3, and last of all here the plus 4 I1, and here is the voltage source. So all are the same direction, plus minus, there's a minus, there's a plus, plus minus, and plus minus. So all the directions are same, so that will be plus 20, 90 degree, equal to 0. So that is the equation number 2. Okay. Similarly, you can do other equation in I3, but there was a current source. So first of all, recognize the current source. Okay. As you know that mesh analysis determines the current. So here's the current I3. First of all, take I3 as 5 ampere in loop 3, because this current flows this loop. So I3 is equal to 5. That has been determined. Just substitute this current to equation 2, and previously in here in equation 1, and here in equation 2, just substitute it, and you can find out easily the two equations, and you can find out I1 and I2, because the I3 is equal to 5, as in this loop I3 just passes through. This is the current source, so you need not to calculate the other KVL or Kirchhoff's voltage law or anything. So while you are using current source, you need not to calculate this. While you are using voltage source, so the KVL will come onto your side. Thank you very much for being with me. There are 3 parts of this video. I will merge it and make you suitable to understand mesh analysis clearly. I hope you will understand it very clearly. Thank you very much for being with me. Thank you very much.